days at Esri. We're really excited to be here and talk a bit about what is happening in our GIS industry, talk a little bit about the trends. Um, Before we start, the question that I'd like to pose to everyone here is, what would your organization be able to do with an extra $36,000? Perhaps bid more aggressively in a particular project, improve some process, hire somebody else to do extra work. Um, as the point here is that as we're showing you all these new trends, think about how they apply to you. Do a rough math in your head about what is happening and what it really means to you, right? So, where do these, $36,000 come from, right? Um, I didn't make them up. This came actually from a couple conversations that I had with some customers last week, and they apply pretty much to organizations that are going and leveraging the cloud and mobile GIS. And it's very simple, right? It boils down to two main elements. It's one is that your time is valuable, right? It's actually, you can attach it to the amount of time. You can come up with a dollar amount of what that's worth at some point. And the choices that you're making actually make a huge difference on the bottom line, right? So in this case, what I'm showing you is numbers from a couple of Amigo Cloud customers that we talked to recently, right? Like one was able to get a process that using traditional GIS software from a very popular vendor was taking them a couple of weeks. And once they started looking at options outside, they realized that they could actually, knock off a whole bunch of time with that and, turn it into 1 hour, right? So they were literally saving, 80 hours every week, and that was an underestimate. In addition to that, they were actually planning on having people out on the field. This is a different group. And they were gonna go and buy some of those Trimble Yuma devices, and whether it's Yuma or some other hardware device from a popular vendor, the numbers boil down to the same thing, right? It's like, what's your price per unit? How many people are you gonna have out in the field? That's how much money you're gonna spend on it. Now, when you contrast that with the fact that I can go to a Best Buy, or perhaps look inside my own pocket and see that I already may have an iPhone or an Android tablet, and that I can actually use that device instead of spending $2,000 for like a rugged, quote unquote professional unit. The numbers start making a lot of sense. So, basically, if these two concepts of saving money and doing more with less, saving your time. If these two concepts are not relevant to you, I can save you a whole bunch of time because basically I'm gonna bore you in the next 30 minutes. But if they are relevant to you, then please stay so, and let's just talk some trends in GIS space. So let's get started. Before we jump into some demos and some other things that we have at the end, I wanted to step back a bit and talk about the current trends in tech and how they relate to GIS. We have come a long way since the early days where we had to carry around our programs and punch cards. Of course, we all know how we transitioned from old mainframes to PC desktops, which is what a lot of us use every day. And this, transition happened at the end of the last century. But the main idea that we had our own local computer when everything we wanted, every time we wanted new functionality, we needed to install software that came from CDs. Like this installed software concept has completely changed, right? Like just recently. And if you look at your current life, you'll realize how that is happening. Nowadays we have switched to a new model without even knowing it. We don't install Google, we don't install Gmail, we don't install Facebook. We just go to a website, log in, and we have a wealth of functionality available to us, right? If we install anything, it's barely small little programs that leverage thousands of servers somewhere else in the cloud. We refer to this as software as a service, software that is either free or paid for on a monthly, yearly basis. So if I want to start doing a particular task, I go and I pay a monthly fee, and lo and behold, it's available to me immediately without having to install any software, right? That's SaaS, software as a service. You'll keep hearing me saying these things. And so make no mistake, right? Like not all clouds are equal. A lot of people tend to, just throw the word cloud like it's just some normal thing. Oh yeah, we're in the cloud because we're running in Amazon. And the reality is that not all clouds are equal, and a lot of vendors that claim that they're in the cloud, they really don't have a SaaS model, because and to analyze and be able to catch these differences, ask yourself these questions, right? Like, can I go and try the software before I buy it, right? Like, go to the website, create an account, just like I can with Facebook, just like I can with Gmail. Go and create the account and try it without talking to a sales guy. If you have to talk to a sales guy to try the software, guess what, right? That's not SaaS. That's just like somebody putting software on some server and they're charging you money for it. Ask yourself, how much does it cost you per user per month? The whole concept of software as a service is that you pay per user seat and you get the functionality right away, right? And if the pricing is supposed to be flexible, right? If you have 5 users or 6 users or 7 users, you should be able to have a pricing structure that accommodates with you, scales up and scales down. A lot of the time what ends up happening is like you'll see a price point where things are at, for 3 users it costs you this much, and all of a sudden the next year is like $10,000 more or something. And that's just silly, right? That's not really a true SaaS. And the third question you need to ask yourself is, does the software that I'm trying out right now, does it have the features that I need? Does it solve the problem? Does it make me more efficient? And that could be, there's so many options out there for GIS, right? And you can ask yourself, am I just collecting points? Am I collecting points, lines, and polygons? Do I need some ArcSD synchronization? Am I doing some ETL, so transforming shape files into file geodatabases, into GML, KML, whatever it is, ETL, right? Am I doing that on the cloud? Is that necessary for me or not? And based on all these questions, you can actually find a vendor that fits that, right? And that's the beauty of it. The beauty of it is that there's many options out there. And so if you take this in consideration, that the cloud and SaaS and all these things are offering you options, a wealth of options with different qualities for every vendor. If you're stuck really with just one vendor and saying that you're in the cloud because that one vendor tells you that you're in the cloud, and you really have not gone out and look at all the different options, you're really missing out. You're missing out in a whole bunch of leveraging the true trends of cloud and SaaS, right? So that's one that we really need to keep in the back of our head. Other trends that are important, I'm going to touch on quite a few. It's open data and open source, right? So open is becoming really the norm and not the exception. Open data is the idea that some data should be freely available. So crowdsourced data sets like OpenStreetMap are becoming more popular every day. It seems that every day we hear about a new city putting their data on some open portal. That's a good thing. But sometimes people confuse these things with open source, right? And open source is being able to look at the code behind the software you use is also becoming more popular every day. It powers cloud services everywhere, and yet there's tons of confusion around it. The first misconception that people have around open source is that many believe that it's an either-or proposition between your proprietary system or your open source alternative, and it is not. That's completely wrong. You can actually use systems side by side that are open source or proprietary. Another common misconception that people have around open source is that they compare open source against commercial software, right? It's like either open source or commercial software, and that's not accurate. Open source software can be commercial, and there can be an entire ecosystem of products and services around it, with support from a vendor. When you go and you pay a vendor that is leveraging open source software, you're basically paying for the service, for the support around it. So That's one that I'm very interested about. And the next trend here is mobile, right? That's an easy one to understand. You know, it's really how we leverage powerful cloud devices. You know, we can basically, with the mobile devices in our pocket, we can play wonderful, complex games that leverage the hardware and the sensors in our device. Yet, when we look at your geospatial software in mobile devices, it's basically still stuck in 1999. Like, you know, for people collecting GIS data, internet connection is intermittent. It is not always available, right? Yet we're still stuck when we think about supporting mobile. We're still stuck with, you know, pure web applications that do not work when the internet is gone, right? Our step back and think about how your Gmail application works, right? Your Gmail application is able to cache edits locally while in offline mode. So the question that I ask is, why shouldn't your GIS software do exactly the same thing? If there's an internet connection, it works connected. If there's not an internet connection, it works disconnected, right? Like, our GIS software should work like that. And so that's a trend that you'll start seeing a lot. Mobile applications that are becoming more like smarter and smarter every day, more than just saying, hey, I have a web app that has a screen that fits in my mobile device. That is just not good enough anymore. This is something else that I think it's relevant for the group here. Basically, when you look at the amount and the wealth of the ecosystem of sensors that are available now that can attach to the mobile device in your pocket, you'll start seeing that now you have options, right? And options are a good thing, right? Because basically, the mobile device that I have in my pocket, an iPhone or an Android, can give me about 5-meter accuracy if I'm outside, ballpark. But it may be that I'm using an iPad that doesn't have the GPS built in, one of the older ones, or it may be that I actually want better accuracy on these devices. So now what is available to me is that there's an entire wealth of external sensors. And in this case, what I'm showing you is some positioning sensors there. And so, for example, if I'm looking for 1 meter, I can go out and get a bad elf device, attach it to my iPhone in this case, and boom, right? My GPS gets better. Or perhaps I may not even need to attach it. I may have some Bluetooth device like the Arrow device here, and I can get highly accurate positioning. Imagine, right? Like, the actual phone in your device is able to play games, like really complex games, and yet, you know, the software is not good enough. And it's usually, but that's changing, right? And now when you think about all the math that you can do in your mobile device, and you pair it with something that can give you highly precise, accurate measurements, now you have basically the best of both worlds. In this case, this is an Arrow unit. We've also used some of the SX Blue units to get centimeter level accuracy. I'm going to talk a little bit about that in a bit. So just mandatory, obviously, you know, we're from Amigo Cloud, so I got to tell you a little bit about what we do. What we're aiming to do at Amigo Cloud is just to create a simple to use geospatial platform that enables people to take advantage of all the trends that we're talking about right now. We want to make it powerful and yet as simple as possible. And I'm not saying go use Amigo Cloud. I'm saying go try it out. Go try out other vendors. Try out everything that is out there and find what's the thing that fits the best for you. When we think about you know, cloud geospatial platform, we're mainly thinking about these 5 items here. Basically, if you're collecting data, we think that out in the field, we think that the best way is not to carry a laptop around, that the best way is to carry the device that you have in your pocket, right? They're super powerful. Why not? You already have them. And if you don't, you can get them really cheaply. So why not? When we think about managing, we're thinking about like how is it the data collection process itself should be collaborative, right? The whole time where we needed to have, I don't know, some process that exports things to shape files, that turns them into GPX files, that loads them into some device in a proprietary format. That's not collaborative. What you want to be able to do is just put somebody's email address, work with 10 or 20 people out on the field, have that entire process of putting data into a mobile device and getting data from the mobile device out. That should be easy, right? And we have big hunking servers out there. And so what that means is that if you're trying to do a conversion of a big, I don't know, GeoTIFF into a Mr. SID file or ECW, like you should be able to load all these things without leveraging a huge infrastructure of computers that are not in your mobile, that are not next to you, right? Anyways, and then the typical stuff, right? Being able to create maps, being able to publish maps. Let me talk a little bit about project that we did, and again, this applies to us, but it also applies to any other vendor, right? So this is a customer that we had that it's obviously a golf course. I'm not going to say exactly who it is, but the problem that they had was that the data looked like this, right? They wanted to have some high precision data about the entire course. And they wanted to go from something like this to this. We actually did all this data collection with an iPhone, with a couple people in one day, no problem whatsoever. And going from this to this may not seem that impressive. Basically you're talking about sand traps, fairways, greens, or any of these things, but it may not seem that impressive until you actually zoom in and you look at the accuracy of the vertices there. We actually did an entire golf course in one day with an iPhone and a high precision device, external device. I think this one was either the Aero unit or the SX Blue. Super cheaply at centimeter accuracy. I think it was less than 5 centimeters. These were basically the requirements that we had: is collect the data using iPhones. The data has to be better than 5 centimeters. Multiple people working together, get the precise measurements, be able to get photos that are geotagged, generate a web map, and export the data out in 40 different vector formats. All this in one day, right? In hours. And so I'd like to, obviously I'm showing a whole bunch of slides, but I think the best thing that I can do is kind of show you what is it that is available out there. And again, just look at it from a perspective of like, I'm going to demo to you some stuff that we can do in Amigo Cloud, but at the same time, there's many options out there that have some of the functionality that we have. And so I want to kind of show you that. Instead, what I should do here is probably have Daniel do the demo. I don't know, Daniel, if you're available here. Here, make presenter.
Hey, can you hear me
Daniel?
now?
Perfect. Can hear you, yes.
Okay, sounds good. Now let me present my screen. Yeah.
In the meantime, while Daniel is setting up, I can answer some questions on the chat, whatever the first questions that come up.
Can you?
So if anyone has any, like a couple quick questions before Daniel fires off, maybe we could do that real quick.
Yeah.
There you go. Now you're on.
Oh yeah. Excellent question. One of the questions is what GPS receiver did we connect to the iPhone? It was, I believe, the ISX Blue 3 that does automatic. You can basically set it up with a public RTK station. So this is the beauty of like the external devices. It's just like the phones and the apps are blowing up out there. Now what ends up happening is that there's also an entire collection of external devices that are also blowing up. So in this example, in California, there's a whole bunch of public RTK stations that have been set up by multiple people. And so with the ISX Blue unit, and actually you can do this also with the Aero units, it's basically you can connect to those and be able to do your corrections in real time, right? It's almost like a Trimble unit that normally costs you, I don't know, $12,000 to get, 0.2 centimeter accuracy, depending on what is it you're looking for. You can do it with, $3,000 devices or $3,500 devices. Really insane. That's one of the links, yes. And I think in our slides that we have a couple of the vendors that we work with that are local in California. There's another one called Aero that actually we are really, really excited about. And yeah, they're actually quite amazing. Daniel, it looks like you're ready.
Yeah, I'm ready. Hear me?
Okay, I'm gonna mute myself here. Excellent question, and we'll have more time later to talk about those other options out
there. Okay. So, this is Amigo Cloud. When you log in and create a trial account, you'll be able to see the same dashboard that I'm seeing right here. And I'm just going to go over a quick example of using Amigo Cloud and syncing to your phone and then bringing the data back in. So first thing you need to do is create a project. New York webinar. And it takes a few minutes to create a project, or a few seconds to create a project. And what it's doing is it's basically setting up the databases and permissions for all the users that are going to be able to connect to this project so that you can collaborate with a bunch of them to collect data. So going into the project, the first thing you see is your data sets, and we're going to upload a few data sets here. This is some San Diego data that is in a zipped up file geodatabase. And it uploads to the cloud, and then we start processing it. We open up the geodatabase, find all the data sets that are in it, and begin downloading it or begin uploading it to your account. If you look on the phone, it's already found that the project has been created. I didn't have to do anything. It's already there, and the data sets are already loading on the cloud. So we can select the project on the phone, and it'll open it up, and it'll begin syncing the data to your mobile device. So while that's happening, we can go back and there were some questions about collaboration. It's simple to invite new users to your project. So I can sit here, I can go to the users, click invite, and type in email. I'm going to invite Raji. And that's all you need to do. Now Raji will be an administrator on the project. He'll be able to see the data sets. He'll be able to download them to his phone. He'll be able to collect data. So going back to that golf course example, you had several people out on the golf course, all of us with our phones and our GPS devices hooked up to them. And we were all, you take hole 4, you take hole 6, you take hole 10. And we all just went through and did our individual parts. And it was all brought together using Amigo Cloud. So now the data sets are here. We can take a look at them. We have sewer mains, water hydrants, quaternary faults, parcels, some business points. Let's take a look at parcels really quick. So this shows us the parcels that are in downtown San Diego. They are around the Gaslamp district and around the golf course, and the conference center is right over here. If you've ever been down there, it's a really nice place. It has beautiful weather. And then if we look on our phone, we see that the same data sets have also downloaded here, and we can select it and zoom in to where that parcel is located here. So same parcel, same data, automatically brought to the phone without having any problems. The next thing we can do is we can start editing the data a bit. So we're going to first edit on the phone here. I'm going to create a new parcel. So I tap the plus button, then I tap parcels, and zoom in a bit, and I give it some vertices, and draws that. And we tap the check, and you can fill out all the fields however you need to fill them out. There's quite a few for this parcel data, as most tax fields have, or tax data has a lot of fields. Then you click save, and it's going to start submitting it back to the server. Close that. And as you see, the server got an update. It noticed the phone notifies the server that the new record has been created and automatically syncs it to the server and automatically brings it there. And you don't have to really do anything. You don't have to click a sync button or anything like that. And the same thing goes for the website as well. If you're over on the website or another user is on their mobile device and they're creating a new record, they can do that here as well. And I'll save that. And in a few minutes or a few moments, it'll automatically bring it to the mobile device. So what's going on here is there's a live connection between the website and or between the cloud software and the mobile device that goes on at any time. You can also go into offline mode. So I can go to settings here, offline. This is useful if you're going to go out in the field where you have limited connectivity or you just don't want to use your cellular data plan because you're not going to be where there's Wi-Fi. And then if you create new faults here on the phone, new parcels here on the phone, and save them. This is going to be cached locally on the phone. As you see, there's a yellow icon in the upper right that tells me that I'm offline, and it's not going to sync. So you could go out for a day and start collecting data, and then when you get back and you're having dinner, you can go and you can put it back in online mode, and it'll begin syncing all of your changes back to the cloud. And then once they're synced, they'll automatically appear for everybody else. So that allows you to take your data automatically to the phone. You don't have to upload it or anything like that. The phone knows about the cloud. The cloud can communicate with the phone. And as a result, your data can be automatically synchronized. If you go offline, your data is just going to be cached onto the phone until you get back online. And then, now that you've gone out and collected a bunch of data, you also have some powerful features that you can use to analyze your data with Amigo Cloud as well. So we can go into the advanced queries here and create a new query. And if you're familiar with SQL, whether it's using it with ArcGIS or using it with PostGIS, you'll find yourself at home writing SQL queries here. So I'm going to select everything from my parcels. And this selects all of the geometries and all of the attribution data. And let's say we want to find out something interesting here. So I was down in San Diego a few days after we had a small earthquake in Redlands. And so I was curious about where the faults are in San Diego because I was down there for the user conference. And if you select all of the coordinary faults, these are the earthquake faults that we know about that are going through downtown San Diego. And I was actually surprised. I expected there to be one. I didn't expect there to be this many so close to each other. So for this example, we're going to we're going to find all of the parcels that are intersecting these faults. However, we first want to buffer it. Like if you're trying to figure out if your parcel is next to a fault, you want to know if it's within a distance of a fault. You don't want to know if it's like, it'll be like, no, that fault is 3 feet away. I don't need to care about that fault. It's like, no, I want to know if there's a fault within like 100 meters of my property. So we're going to use a simple geospatial operator to buffer the coordinary faults here. So we're going to select SD buffer. WKB geometry 0.01 from datasets. So let's execute that, and we can see we have a small buffer. Let's make it a little bit bigger. So this buffer is in actually decimal degrees, which is not a real useful measurement because nobody really knows decimal degrees. So let's change it into a meters. So we're going to change this to geography. And then we're going to give it 100 meters, and then we have to change it back into a geometry. Let me execute that again. And this is actually, it looks similar, but this is actually 100 meters exact. So this allows us to use coordinates that we do know, our linear measurements that we do know, and coordinate systems that are actually decimal degrees. So we're going to save this query, buffer faults, and we're also going to create another data set with it. So now we go back to our queries, and we can see that the query has been saved there. So if we ever get a new fault or something like that, we can always come in and re-execute the data. Also, if somebody was going out there in the field and they were measuring faults and they digitized a new one, we could use this to rebuffer the faults as well. So we're going to create a new query to find our parcels. So we're going to say select star from our parcels, and actually we need to do, we want to select everything from the parcels, and our buffered faults, which is our new data set that we just created, where st intersects and our parcels.wpp geometry and a second intersect parcels. Yeah, okay. And yes, I didn't give this a name for the field again. Let me do this again. WP geometry. Otherwise, it has kind of an odd name. Save that. Overwrite the query for later. Create a permanent data set. There we go. That's the process you go through to rerun a query and create a new data set with it. So now we can intersect it a lot easier. So we want to use buffered faults too, and buffered faults to geometry, and execute that. And these are the buffered faults. So now we found all of the parcels and all the partial data that is intersecting any of the faults within 100 meters. So this is interesting to us. So we're going to create another data set. In danger. Parcels in danger, yes. Save that data set out. And then we go back to our data sets list. And we see our new data set here. So we want to share this data set out with people. Say, for example, we're an insurance investigator and we're like, hey, we want to, go sell insurance to people, but we really only want to target the people that have money to buy insurance because earthquake insurance in California is kind of expensive. So we're going to come here and we're going to create a choropleth map using ASR total, which is the assessment total for the land value. I'm going to choose 7 buckets because I think it looks better, and click Save. And so this tells me where all of the most expensive parcels are within 100 meters. So you can go visit all of the individual people here. So like here, I could select this parcel, and the owner name is 13th and Market Properties LLC. So I need to go and find the owner of this company, have their address right here. I can send them a letter, and I can send them a link to this map just by sharing it out. So now that the map is created, we simply click Public Map and click the link for it. And this actually looks pretty good. So we zoom in a little bit. And then from this point on, you could create like a bit.ly or a smaller URL. But then you can share it out with somebody, and when they go to look at it, they're going to see the same map that you saw. So that's one way to share out data. The next way to share out data is important for small government organizations and nonprofits. As Raji was mentioning earlier, open data is becoming really, really popular these days. A lot of citizens in their countries realize that people are collecting data, geographic data about them, and whereas before, if you want to get the U.S. Census data or something, that might be a complicated thing. And as the technology is changing and improving, it's becoming a lot easier to create open data portals. So here's Amigo Cloud's open data portal, and I'm going to create a small one here, and we're going to share out the parcels in danger buffered faults, the original parsers, and the faults. And click OK. And then I'm going to say parcel earthquake data will be the name of the page. Click Done, click Save and Share. And now we have a link to an open data portal that we can also share with other people who are curious about this. And when they go to it, they'll see something like this. It gives them the outlines of where the data is, and then they can download the data in a bunch of different formats. PDFs, shapefiles, file geodatabase. Here I can download the buffered faults as, actually let's download this. We'll download this one as a KML. And they're going to send me an email, let me know it's ready. I click OK. You notify me. OK, yeah. OK, that's good. And what it's doing in the background is it's processing that data. And I don't have it quite yet. And when it's done processing the data and converting it to KML, I'll get an email with it. While we wait for that, you can also, if you also want to only share data with people inside your organization, they can just go to the dataset list and export it here. And it'll do the same thing. Let's see, it's downloading it. Okay, here's my parcels in danger shape. I actually wanted that as a KML. Okay. There's my KML. Now that I have a KML, you can double click on it. And so the reason open data portals are really good is you can use them to share out your data. Just a second. Close this. And here it opens it up in Google Earth, which will zoom right into the data. And this is the data loaded into Google Earth. So whether or not you export a shapefile and you give that to somebody who might have ArcGIS, or you export a KML and give that to somebody who might have Google Earth, or you just give them a URL to the web map online, there's various different ways you can share out your information to different people and help them learn more about the geographic data that they have around them. So I think that's about everything. Showed offline mode, online mode with the mobile device, syncing it to the website, and then being able to share that data out with others and bringing your data in. So that wraps up my demo. Does anybody have any questions?
I have a question there.
Hey, Daniel, let me...
Go ahead, Raji.
Go ahead.
I was going to ask
I was
a
going to
question
say
about satellites and everything for when you go out there for doing your position and everything, when you acquire that information. Is there a set number of satellites as a minimum that you need to acquire so you can get pretty good accuracy for the different levels?
Oh yeah, that's Daniel. So let me actually interrupt.
Do you want to take a question, Raji?
Yeah, please. Actually, I noticed that in the participant list we had Brian Mickle, who is been basically working with us. It's one of the vendors, one of our preferred vendors that we use with. It's an expert in receivers. So let's see if I can have them answer that question instead. I know that the short answer is that basically, obviously, you need a certain amount of satellites. And actually, most of the devices right now support connecting to GPS and GLONASS and multiple constellations. Brian, do you have the voice set up? Not sure.
And then we have data dictionaries like TerraSync. Can you set them up, or like even catalogs and that, image catalogs and different things of that nature if you had to?
Yeah. So the answer is basically with our solution, what we want to do is make sure that you can leverage what you already have. So you basically can use our API to load in some other data dictionary that you have. You can use our web interface to create the data dictionary from scratch. Or if you have our GIS, and let's say that you already have your domains and your coded value domains, range domains, relationship classes, whatever it is that you already have set up in your file geodatabase, we have a synchronization tool, an extension inside ArcMap. So you basically just point to your geodatabase, you hit run, and it'll extract the data dictionary of your geodatabase and create equivalents in the cloud and in the mobile device without you having to do anything. It's a one-click solution. Does that answer the question? I assume it does. All right, great. Thank you. Are there any other questions?
Another one's coming in right now, I believe.
Oh, I see Brian is there. Perhaps.
Let's see here. Do you have the restore interface to the data store?
Yes, actually. Daniel, do you mind showing the API there, the API browser?
The API browser? Sure.
Yeah.
So you access the developer API through this menu right here. And the website and the mobile device and the ArcGIS geoprocessing tool also all use the same API. So anything you can do through those, you can do through this API. So looking at my user credentials here, you can see my name. I'm echoing off somebody. Okay, you can see my name. You can also see my projects. Tells you everything there is to know about the projects, what data sets they have in them. From the data sets, they're asking about the data dictionary. From there, you would go look at the schema of a particular data set, and this is where the data dictionary would be stored, where it says this field has these coded value domains or has this range domains. This data was imported using just a file geodatabase and the open source importer, so it doesn't contain any of that information. But if you were to use the geoprocessing tool, which is actually right here, I didn't demo it, but this is the geoprocessing tool, and you type in your username, your password, the name of the project, and click OK, and it'll sync all of the data to your data set. And it will bring over your coded value domains and your range domains, and you will see them there in your schema of the data set. Does that answer the question? Cool.
Yeah.
Great.
So,
and the question I have is how easy of use would it be to generate your field forms so they would go out and collect the data? So say I had like an SDSFI compliant database where I have a set structure to begin with, and I just only wanted in to capture.
Are you starting with data you already have existing, or are you starting from scratch and you want to create data?
So I'd say I make like a personal geodatabase, and I'm adding my columns, or the columns are already pre-existing based on a set structure. So I have the column names and I have the lists and everything like that, but there's only, out of like 25 of them, I'm only filling in like 5 or 7.
Okay, on your form, you only actually want to see 5 or 7, right? You don't want to see all 25. So to do that in Amigo Cloud, let me come back here. Let me show you that. Oh, this is the map preview. Sorry, I got a little lost there. All right, so this is Amigo Cloud. So every single one of these things comes with some mobile sync settings. You can choose whether or not to show the data set on the mobile device or allow the data set if offline. Those are useful for some really large data sets. So if you import data that you actually don't want to see on the phone, it's only there for contextual reasons or something on the website, then you can turn it off there. So that's one way of hiding data from the mobile device. The next way of hiding data is to open up the schema, and you look at the fields and it has a visible attribute. This can be used to hide the data as well. The next way of hiding it, yes, I don't want to change it. So the next way of actually customizing the forms is to go to the mobile forms, and this is where you can customize the mobile forms here. So I could come in here and put H1 by header. And you can use this to, to customize the mobile forms and remove fields that you actually don't want the user to fill out and that kind of thing. If this is a really more advanced case, so only people who understand HTML and JavaScript will want to do this right here. We've helped quite a few people modify the forms a little bit to make them a little bit more user friendly, and we're constantly improving this as well. Does that answer the question?
What I'd like to point out of this particular thing is that Daniel is basically showing 3 or 4 different ways of customizing the forms. The goal with it is to be able to do the whole thing. If you want to add custom code, there's ways to add custom code. If you just want to uncheck and hide some fields, you can do it through a nice interface. If you want to go down to the weeds and add custom behavior with JavaScript, then you can do that. The goal, again, is that he did all of this, right? The customization of the code, all the way down to being able to have an interface to hiding things without having any software installed, right? It's all SaaS. It's all in the cloud. You just clicked a few buttons, nothing installed. And I think that's what the big differentiator is. Otherwise, if you have to change some code and anybody has done this, there's an entire deployment process of this where you have to, even for iOS, right? If you had to change code and add custom things, you have to grab the file, submit it to the iTunes store, wait 2 weeks before it gets deployed. Now all they have to do is go in there, change the JavaScript or the HTML, and the thing gets deployed within seconds.
Yeah.
Are there any other questions? And I think we still got time probably for one more.
Very nice.
Yeah, as Rob's saying, it automatically syncs with the mobile device too. So you can see that the header I just added in there is already synced there. The phone is paying attention to when the forms are changed as well. So you don't have to have some massive redeployment thing, to get it on everybody's devices. They just launch the app, it syncs, it's there.
An extra feature there too that I think it's worth pointing out. It's a very common use case when people do things like, let's say that you are using one of the collector apps or something like that. If you are changing the schema, then automatically what it does is it invalidates all the other geodatabases that are in all the collector devices. Like every time you change the schema, you have to resync everything, and then if you haven't checked in all your changes, you basically lose all your data.
All right, gentlemen. Well, the presentation. There's a lot of leverage you can use this against and everything with the application that's been designed, especially doing a lot of field work and for the synchronization between the time.
You're welcome.
Yeah, you're welcome. Thank you so much.
Thank you for having us.
Likewise.
I appreciate it. And what we'll do is I'll stop the recording here in a little bit, and then I will have it posted on YouTube, and then it will be archived on the New York State GIS Association website as well. And then I'll provide links for you guys.
Thank you. And if anybody wants to try any of this stuff out for free, you just go to amigocloud.com. There's a sign up on the upper right. Go click on it. Download your Android app or your the app from the Google Play Store or the app from the iTunes Store if you have an iPhone or if you have an Android device, and just try it out. I mean, that's the best. That's the beauty of it, right? Go to any other cloud providers and see what they have, and if it fits your needs. And we'd love to talk to you. Thank you again for having us, and yeah, we'll talk soon.
Thank you again.